today's webinar as a resource person. Sir, it is indeed a great honor to have you, sir. We extend a warm welcome to you.
Thank you.
As per our Indian culture, we always start our program with Saraswati Vandana. So I request our IT consultant, Brij Mohan, to play the Saraswati Vandana first.
या कुन्देन्दु तुषारहार धवला या शुभ्रवस्त्रावृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युतशङ्करप्रभृतिभिः देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा।
Request Dr. Amit Datta, sir, Director, Student Development Cell AICTE, to deliver welcome address for this webinar.
Thank you, Sanjuji. Warm good morning to one and all from AICT headquarters here in New Delhi. It's my proud privilege to address this August gathering, dear students and academic leaders. The National Education Policy 2020 has set the bar high for the higher education institutions in the country. It envisages the nurturing a vibrant campus life, incorporating a holistic and multidisciplinary approach to imparting education with the objective of developing a workforce with its creativity and multi-talented. This calls for a holistic education ecosystem which goes much beyond the traditional curriculum teaching. A focused pursuit for the co-curricular activities, project guidance, therefore would be a key for achieving the NEP 2020 goal. It empowers us to strengthen the memory, stimulates the problem-solving skill, sharpness the focus and concentration, enhances the lateral thinking and creativity, critical thinking, ensures a decision-making bent for the man, provides a sense for accomplishment, and builds confidence. At a time when the job market is getting increasingly competitive, all the above togetherness are a sign of a building bright career. I would like to welcome you all for this auspicious occasion. And today we are fortunate that Professor Gupta sir has given his consent to guide you, all the students, for the interdisciplinary approach and requirement of the industry 4.0. I once again welcome you all, and I wish you will not only earn here, you will not only lavish your knowledge, you will have a great cherished session today. Thank you so much, and once again welcome you all. Have a great day ahead.
Thank you so much, sir. May I now would like to call upon Professor Vijay Kumar Gupta, sir. He has interest in the area of smart structures, vibrations, FEM, mechatronics, and robotics. He was recipient of ISAMP K. Surya Narayan Rao Memorial Senior Student Award for R&D in Smart Technology for year 2003 for his research PhD work. For his PhD, he worked on the shaping and steering of antenna using piezoelectric actuation. He is also recipient of JSPS Short-Term Invitation Fellowship. He has published more than 50 research articles and edited 3 books. He was chair of 3 international conferences and supervised students in a number of theses in the area of mechanical design, condition monitoring, mechatronics, and robotics. Sir, I request you to please enlighten all of us about the project opportunities available for PG and UG engineering students of Mechanical Engineering branch. Sir, please.
Thank you, Dr. Datta and Mrs. Chaudhary. Thanks for inviting me for this webinar. Unfortunately, there is some problem with my video, so you will not be able to see me. It was initially started, but there is some problem. But thanks for inviting me, and my today's talk will be basically focused towards the what are the opportunities for mechanical engineering and with particular focus towards the interdisciplinary aspects. So I planned this presentation based on that. What are the future of the mechanical engineering, particularly in the area of the interdisciplinary aspects. So I hope you are able to see my screen in presentation. Okay. Thank you. So let me introduce myself that I am professor in mechanical engineering at IIIT DM Jabalpur. IIIT DM Jabalpur is one of the 5 government aided information technology institutes. IIIT is basically, there are later on 20 more IIITs have been added in PPP mode. And this IIIT DM Jabalpur was the first which was established with the focus towards the design and manufacturing. So IT enabled design and manufacturing is the main focus area for this, and accordingly we are moving in this direction. Being in mechanical engineering, I have interest towards the other interdisciplinary area. And as you know that NEP has changed a lot, the focus of the NEP is towards the interdisciplinary aspects itself. So I hope that today's lecture will be helpful to you in getting your future directions towards the interdisciplinary aspects in the mechanical engineering. So I start, voice is not coming properly. Just let me just see. Is it clear now? Am I audible now? Okay. So I started this basically. We take the example of the locomotive engines in long back when the steam engines were developed. The first type of locomotive engines were developed were based on the steam engineering. So this is the example 1868. You can see that this was the steam engine being developed. Later on, the technology changed, and then steam engines were replaced by the diesel engines. So we had seen the changes, and then I'm just showing one example here, but there are a lot of changes changing from the steam engine to the diesel engine. And today, if you see all the Indian Railways.
Audible, sir, audible.
Okay, thank you. So today, if you see that the railway engines in India, they are running, most of them are running on the electrical engine. Same is the case with the automobile. Basically, they started with the diesel and petrol engines, and now we are moving towards the electrical vehicles. So there is a lot of changes in the technology, advancement in the technology, and we have to move with these technological changes because in future, if we have to survive, we have to keep on changing our skills based on the requirements. If I take the example of the engines, our motorcycle or cars, you see that changes. Basically, the previously the job was only the mechanical only. Even the supply of the fuel inside the engine was controlled through the cam and valve mechanism. And now we say that everything is controlled by the electrical control unit. So ECU has replaced the carburetor part and the injector part, right? So the world is moving that they are from pure mechanical or pure engineering, we can say in one discipline to the multidisciplinary aspects. Now we cannot say that being in mechanical engineering, I cannot have a focus towards the basically how the engine will be coming. That is a job of the electronics engineer or electrical engineer. They will be doing the repair work or whatever adjustment. They will be only be doing. I cannot do that. Then in that case, the work, whatever work is there, that will be suffering, and then the survival becomes a difficult. So we have to learn that being a mechanical engineer, we have to learn what are the aspects related to electronics, control, and other aspects. So with this aim, basically, I planned my lectures for today. And if we see the World Economic Forum, the future of the job reports of 2020, it says that almost 50% of all employees will need digital upskilling by 2025. So whether you are a mechanical engineer, whether you are a civil engineer, or you are a worker in the industry, manufacturing, maybe the fitter or maybe some other gunner and other jobs, I'm having focus towards the mechanical because this talk is towards the mechanical engineering only. So my examples will be mechanical engineering related only, but all of them needs the upskilling in the digital. We see the changes in the mechanical engineering, in the manufacturing aspects also. That the previously the conventional lathes were being used in the industry. Nowadays they are being replaced by the CNC, NC and CNC machines. So there is a change. Basically, when we have to work with the NC, CNC, we require the knowledge of the coding so that we can perform the required job. So based on the current trends, basically the 2020, the World Economic Forum, they conveyed a survey, and based on that, they given that by 2025, most of the workers, most of the engineers, they will be requiring a digital upskilling. So everyone should be knowing the computers, how to handle the computers, how to control the machines using the computers. That is the requirement for the future. This is the same report. If I see the changes. Now today we see that the demand for the mechanical engineers, as we see from the admission point of view, we see that the first choice for the everyone is towards the computer science and engineering. If I get a computer science and engineering, I can perform good or I will be having better opportunities, right? That is the trend. But if you see this report, which was based on the survey done by the World Economic Forum in 2020, it was conveyed in the different countries. India was not a part of this, but we see the changes actually. If you see the changes, green color shows the positive changes, means there will be increase in the demand, and this brown color shows that there is a decrease in the demand. So this is the overall, basically you see that there is an increase in France, 24% increase will be there. Hiring will be more. In United States, it is almost stagnant. UK, it is minus 4%, and other places it is like this. If we see the different domains in which the hiring of the persons will be there, what will be the hiring trend for the different jobs basically? If it is a consumer goods industry, you see that from August there was a 8% increase in the hiring for the France, right? While there was a minus 11% decrease in the hiring in the United Kingdom. This is the data for the finance. And if I go for the mechanical engineering, basically the manufacturing point of view, you see the change basically that there was 20% increase in the hiring for the manufacturing sector. It includes mechanical engineering as well as the other type of engineers also, but there is an increase in the demand of the hiring for manufacturing industry. And if we see the trend for the software industry, this is August 2020, and you can see the change. As compared to mechanical or manufacturing industry, the jobs in the software and IT industries, they are decreasing. It's because there are more number of persons being employed, and then it is being. So the job is towards the manufacturing, it is increasing, and if we train ourselves towards the requirement of the manufacturing industry, it will help us in getting the better job opportunities. From the same report, if you see that technology likely to be adopted by 2025, this gray color, if you can see here, it shows the changes basically, difference. As compared to 2018 and 2025, this is the change. So there is a requirement, basically 75% increase in the cloud computing technologies. Big data analytics, you see the change, it is only 2% change basically, right? There is a large change in the Internet of Things and connected devices. So this is the area where mechanical engineers can play an important role. We have the area, basically, you might have heard the Industry 4.0. So through Industry 4.0, if we train ourselves towards the technologies required for the Industry 4.0, there is a change in the requirement, basically 9% changes are required. Then there is another cyber security. There is a 8% increase predicted for the artificial intelligence, machine learning, and these technologies. Right? Deep learning, machine learning, artificial intelligence. So these are the future directions in which all the engineers can work. It is not that only the computer science people, they will be doing the artificial intelligence job. A mechanical engineer can also train itself towards the artificial job intelligence. I will show you how we can do that. Some example I will be taking. Another area is this robotics, industrial automation, and drones. So robotics, they are divided into two parts. One is towards the industrial automation. Drone, you know that there is a lot of requirements about the drone technology nowadays. Drones are being used for various purposes. So there is a 10% difference is expected, 10% increase is expected in this area. Here also the mechanical engineers can play an important role. 3D and 4D printing and modeling. Again, you know that 3D printing and modeling, it is mostly from the mechanical point of view. So there is a change, positive change towards the mechanical engineering. Biotechnology, it is being developed. So there is basically this Bioengineering is another direction. Basically, I will not say the biotechnology because biotechnology focus more towards the biology and chemistry point of view, but bioengineering for surgery. And if we see nowadays in the COVID paradigm, we had seen human health monitoring. For these purposes, we can play an important role. So there is an 8%. Here it is biotechnology, but bioengineering is also playing an important role. Robots and humanoids, particularly in COVID paradigm, it has been felt that the humanoids or social robots may play an important role for the world. So there is a lot of research which is being employed, which is being used, which is being developed towards the social robotics. It may be that we are helping some physically handicapped person by prosthesis hands or prosthesis legs. It can be that someone is alone and a robot can go because of the COVID. Direct contact is not possible, but a robot can go there. It can interact with the person so he can feel good. And then after coming out, it can be easily sanitized. Sanitization of human being is difficult, but robots can be sanitized by UV rays and others. So these type of jobs can be there, and then there is an increase in demand in this area. So this gives an aspect that there is a lot of scope for the mechanical engineering students and mechanical engineers, but we have to adopt the technologies which are changing. We have to adopt the technologies like Internet of Things, like robotics, 3D printing, and other technology like NLP, machine learning, AI, etc. Right? So based on a Deloitte survey, basically growth of the engine machinery sector, they had identified that there are 8 future initiatives required by the industries. And if you see this first and foremost initiative required by the industry is that digitalize your core processes. So the future of Indian industrial manufacturing is both combination of mechanical and digital, and we have to train the mechanical engineers towards these aspects. Other aspects I am not taking, they are general actually, but I wanted to emphasize on this basically. And from the same 5 key skills required for the industry 4.0, that requires the digital skills, technology and computer skills, programming skills, and in addition, we have to keep our mind open. We have to critically think about the aspects, and then we can do the job. So this critical thinking or change in our thinking process will bring the major change in our demand for the industry. And obviously working with tools and techniques will be always required, so that is there. I've gone through the SME Vision Report 2030 that states that the curriculum for the mechanical engineer, according to SME Vision 2030 report, it needs for innovation and creativity and more authentic practice-based engineering throughout the curriculum. What is happening today, and in the last 2 years, if I see it, everything was going on in online mode. So in online mode, we can give, as a faculty, because I am a faculty, I can just give you the technological aspects in theoretical fashion only. But when we actually work with the real practical thing, there are large changes from the theory, large difference between the theory and the practice. And this practice can only happen when we work with our own hand. If I see, actually, based on my experience, we see that when the first students enter in the first year of the UG, they are very much afraid of the computer programming if they had not taken that in their 12th. The programming becomes a hova for them, and then they try to avoid sitting on the computer and then making the programs. They think that it is a job of the computer science only, but as a mechanical engineer also you can do the programming. Programming does not require a computer science knowledge. It requires, there is some problem with the sound.
No, sir. No, sir.
Okay, okay, thank you. Because I'd seen some message, so that you, okay.
No, sir, your voice is perfectly clear.
Okay, thank you, thank you. So if I see that from the mechanical engineering point of view, when you start working on the computer, what you require is for programming is that your thinking process. That if this is the job given to me, how I will be completing this job, think on that aspects, some basics of the programming you learn, and then you can program. And nowadays, basically the programming also becoming more easier. Initially, the scientific programming language was Fortran. Later on, the C came, then C++ came, and now the programming language, if you see, the Python is taking over. And programming in C or Fortran was much tough as compared to Python. So based on that, I can say that when you will start learning the programming language, slight initial hazard will be there, but afterwards you become familiar with the programming language, and you will be developing your programming aspects easily. You will be getting an interest, and later on you can do most of the things by you. So when you practice, actually that makes a major change as compared to what we teach in the theory. Theory is required, basic fundamentals are required, but for an engineer, particularly for mechanical engineering, I will emphasize that the practice-based engineering is more. So you have to perform the experiments, but PG also, nowadays what we do is we are using the simulations tools only. But if the results of the simulations will only be validated through the experiments. So experiments are also required, because otherwise it is the computer, we say that it is the dumb box. But if I give the garbage inside, it will give me garbage outside. So we have to learn that, right? So accordingly, the SME's vision, American Society of Mechanical Engineers, they emphasize that the curriculum should be more practice-based engineering rather than the theoretical aspect. Obviously, theoretical is required, but practice is also, right? So they recommended that more hands-on activities like design, build, and test. You design yourself, design yourself, and test. So innovation is another aspect which is now being emphasized by the AICT as well as government bodies also. You try to innovate, develop the new things. So in that you have to design yourself, build it, and then you have to test. Right? Emphasize on the communication, and develop a system perspective rather than a component based. Right? So you have to develop a perspective which is system based, right? Okay. So these are the some future interdisciplinary areas where mechanical engineers can contribute. I am having focus towards interdisciplinary aspects only, so I not cover the energy and other aspects, right? So, and I will be giving you some insight, basically one by one requirements. I will be giving the technologies which are involved in this area, basically. So, if we see the electrical vehicle, the government of India is having emphasis because if you see today's the war between the Russia and Ukraine, it has affected the oil prices. It is almost increased to 120. In between, it has increased to 140 as dollar. So there is a large increase in the fuel cost, and if fuel cost increases, it affects the economy of the whole country because it is not only our transport, it is affecting the transport of the goods. So goods prices will also be increasing. The day-to-day commute of the persons will be increasing. So in that also the vehicles are being used. So there also the cost is increasing. So all that is having a great impact on the economy. So from moving from the conventional vehicle to the electrical vehicle is taken up and the government of India is doing. The major challenges in the electrical vehicle is the battery. How to manage the battery and the charging of the battery. So we say that the e-mobility and that. So if I convey this, I have taken from the government of India, basically energy side, basically. And e-mobility, if you see the changes between the conventional vehicle and the electrical vehicle side by side, you say there was a IC engine inside the conventional vehicle and it has been now replaced by the electrical motor. It can, mostly it is the DC motors, so AC DC motor conversion and all that is there, right? Obviously, gear ratio will be required. So gearbox is still a part of the whether it is a electrical vehicle or it is a conventional vehicle. The major change is between the engine, basically. So instead of IC engine, now we have the electrical motor. And with this change, basically, you see that the fuel tank is replaced by a battery bank, energy storage in the battery. Other chassis, steering part, the braking part, that remains the same. Obviously, there will be some changes because of the power requirement and other aspects. But the conventional things can also be used in this with some minor changes. So you see the technological changes which has happened, and still, if I have to build a car, there is a requirement for the mechanical engineering because most of the parts in the car are still mechanical parts. Only a few parts are electrical, but these mechanical parts, we say that it is not mechanical, they are mechatronics because they are being controlled by some electronic devices. ECU is one of the major part of the vehicles nowadays. So there is a requirement from changing from the mechanical to mechatronics. So this is the aspects related to mechatronics. What is mechatronics? It is basically the combination of the four technologies. It is a combination of mechanical systems, electronic systems. Electronic includes the electrical part also. So electronical systems, computer systems, and control systems. So combination of these four technologies is basically the mechatronics. And if we see the combination of mechanical and electronics, it is only electromechanics. If I combine mechanical with the computer, it is the mechanical CAD or CAM we say. Computer and control system is digital control system, and then computer and electronic is control electronic. And all these four aspects combined together is the mechatronics. And mechatronics is being employed in most of the industries today, whether it includes the automotive industry, aerospace, defense industry, medical industry, other industries. So what we require is a mechanical systems. We require some sensors. The sensor may be digital sensors or analog sensors. So these sensors will be monitoring the mechanical systems. So they generate an analog signals. Basically, most of the sensors, they will be giving you the charge output or the electrical output. So that is why they are analog sensors. Now, after that, we convert them to the digital form. So there is an analog to digital converter. ADC, basically you might have heard the term microcontroller. So microcontroller can be used to convert this, or there may be some electronic circuits which can convert the analog signal into the digital converter. Then these signals are fed to the microprocessor based control systems, mostly microcontroller or PLC in the industries. For this purpose, they are being used. These signals are being analyzed, and then the corrective actions or whatever actuation is required, that is being done. So that output signal will be given by the microprocessor. Microprocessor will be giving a digital signal. So it needs to be converted to an analog signal. So we can use some digital actuator or analog actuator, which can then actuate the mechanical system. And this total system becomes a mechatronics system, right? So, and we see that mechatronics is all around us, whether it is the computer hard drives, robotics. We use the washing machines in daily uses, the coffee makers, microwave. Most of the medical devices, they are also of mechatronics nature nowadays. And then there is some electronics that control the mechanical systems. So that is, I had already given the example of the automobile ECU. It is used for the stability control, anti-lock brake system, climate control systems, memory adjustment in the seats. These are the developments basically in the vehicle technology or automotive technologies. This is one example where the mechatronics or robotics is being used in the industries. Number of robots are working and they are doing different jobs. They assembly, welding, painting, other jobs. Right. So coming to the robotics, basically robotics is a wide area. So we divide the robotics into three major basically areas. One is the manipulator, industrial manipulators like this in the shown here. So they are being used for the industries, and basically their purpose initially was that how we can replace a human arm. So that was the purpose, and based on that the manipulators have been designed and they have been developed. Later on the technology moved towards the mobile robotics. So we see the mobile robots like it's for space Mars exploration, or it can be the humanoid being developed. And you see I think it is the Atlas. Boston Dynamics, they have developed the cheetah which can run. They have developed the robot like Atlas, which can take the jump also, and then it can stable. So whatever a human or animal is doing, the robotists are trying to develop the same things with the help of mechanical and electronics aspects basically. And obviously the programming will be. So robotics consists of mechanical aspects, machines, mechanism, their design, then designing of the whole system so that the load can be carried and all that aspects will be coming. Then there are electronics aspects because motors are there which can need to be controlled. We have to convert the signal from analog to digital signals. Then robots require a feedback, proper feedback. So control is required, control systems are required. And in the control systems, we require the handling of the data also. Nowadays, robots are becoming intelligent, they are becoming autonomous also. So when we are making something autonomous, we have to use the artificial intelligence because we cannot feed every instruction. Then if this is happens, then this will has to be done. We cannot do that. So we have to impart the artificial intelligence. So if you see nowadays, the focus is towards the AICT. This artificial intelligence, deep learning, machine learning, these are the aspects which are, and they require the data analysis. So data analytics is another aspect for engineers. Coming to the other aspects, which is for the mechanical engineers, is the Industry 4.0. So McKinsey and company, according to them, Industry 4.0 is more than just a flashy catchphrase. It is a confluence of trends and technology promises to reshape the way things are made. And if you see this, basically, the first era was towards the mechanization, steam power. Then the second industrial revolution was towards the mass production, assembly lines and electricity. Third revolution was towards the use of the computers and automation. And now it is the cyber physical systems, Internet of Things, which is being imparted in the manufacturing industries or industries. So Industry 4.0 is based on the 9 technology basically. These technology includes the advanced manufacturing solutions, which includes the autonomous cooperative industrial robots, numerous integrated sensors and standardized interfaces, the control NC systems, CNC systems, etc. So if we train our mechanical engineers towards these advanced manufacturing solutions, they have a major role to play in the industries because the industries are moving towards the Industry 4.0. Previously, when industries were designed, industries were considered that conventional industries that this job will be done first, then this job. For example, suppose I am making a nut, simple nut. What I have to do is I have to first turn it and then I have to cut the threads. In between, I have to put some fillet and other things, right? So there was a conventional process basically that first the job piece is required, then it is to be turned into full shape, then step turning is to be done, then threading will be done, chamfering will be done like this. But with the introduction of the additive manufacturing, we can perform all the aspects through the 3D printing itself. So there is no need to send the job piece at different places. In one machine itself, we can perform all the aspects. So we can create a CAD geometry, we can generate an STL file for the job, and then we can send it to the additive manufacturing 3D printer, and it will be printing the job basically, right? And the technology has advanced. Initially, it was developed for the plastic. Nowadays, these metal 3D printers has come, and the future is towards the printing of the bio implants. So people, researchers, they are working how we can print the bio implants also. These are the technology. And here also for mechanical engineering, we can play an important role. We can develop the machines which can do these type of jobs. So right? The third aspects which resulted in the development of the industry 4.0 is augmented reality. So from a remote place, I can see what is happening at the shop floor. So I'm giving this lecture from Jabalpur, and you are listening this lecture at your place. It may be at Delhi, it may be at other places also. Sorry. So how it is happening? Because of the development of the internet technology and digital technologies. So augmented reality, what we are doing, we are sending the activities data related to shop floor to a manager or to an engineer at remote places. And we can see, or we can perform the maintenance, we can perform the logistics required at the shop floor through a remote place, right? Simulations, because everything cannot be built, it requires a lot of expenditures. So simulations plays an important role, and lot of simulation tools have been developed. We have the CAD simulation softwares like CATIA, SolidWorks, ANSYS, Abacus, which can do different jobs for us. They can do the CAD drawing, they can be used for the analysis purpose, stress analysis purpose. If we use the ADAMS, we can do the kinematic analysis also. So simulations are helping in the industry 4.0 also. And with the industry 4.0, the industries are now changing towards the horizontal and vertical integration. Previously, it was the vertical integration. So there was shop floor, then shop floor manager, then from shop floor to the section managers, section manager to the factory manager to the whole, basically the group manager or the MD, managing director. That was the previous structure or hierarchy in the industries. Nowadays, we can transfer the data horizontally to the other places. So the shop floor data can also be viewed by the MD, managing director. It can be also seen by the customer also. So there is an in horizontal integration also, and that is required in the industry 4.0. I'd already discussed the internet requirement of the internet in the industry 4.0. So this changes has played an important role. Obviously, when we are sending our data from my place to a other place, the cloud plays an important role. So managing the cloud computing. So we can do the, nowadays, if you see these software, simulation softwares, they are also becoming cloud-based softwares. So they are big, right? Now, when we are sending the information from my place to the cloud or from cloud to the another place, the security of the data is an important aspect. So cyber security aspects are required. So here the computer science can play an important role. Cloud computing also, the computer science can play an important role. But in these aspects, from 1 to 5, mechanical engineers can also play an important role. And then, because everything will be generating the data, we have to handle the data. The data will be collected at every instance. It may be at the rate of few seconds or microseconds also. So a large number of data is to be generated. We have to analyze this data. So big data and analytics play an important roles. Or in this analysis of the big data, basically, mechanical engineers can play an important role. So in Industry 4.0, the aspects, there are aspects where mechanical engineers can play their roles. It's important, right? If we see, this is the industry smart manufacturing systems. So the role of the mechatronics, smart product design, predictive maintenance. Because Industry 4.0 requires the maintenance of the component machines, predicting the condition of the machines, and then taking the predictive maintenance is also in aspects of the Industry 4.0. Right? Then energy management and machine tools 4.0. Right? In addition, in Industry 4.0, the robots, because what is expected that the human being will be working and robot will also be doing the job, and they will be doing the job simultaneously. So a cooperative robotics is another area where we say that cobots. So human being and the industrial manipulators, they will be working in collaboration with each other, and the job of the industrial manipulator is that it should not harm the human being. So accordingly, the developments have been placed. There are role of the sensor in here. Safety of the worker is to be taken care, and then this is to be taken. Another aspects of for the future mechanical engineering is I am taking the smart structures. Smart structures are the structures where the controls and then taking a corrective actions are being placed. I say that human beings are smart because when we touch something hot, we immediately remove our finger or our part which is touching the hot part, hot component, we immediately remove. So that means we have the sensors, we have the controller, and we have the actuators. So smart structures are basically the structures which incorporate all these aspects. And we use different materials. For example, piezoelectric is there, shape memory alloys are there, electrorheological field, magnetorheological field. These are the aspects which are there. And researchers are going. I'm taking only one aspect of these smart structures, which is the energy harvesting here. So this includes the electromagnetic harvesting, electrostatic harvesting, and piezoelectric harvesting. So what is being done here is that vibrations which are generated our nearby, we can convert them into the electrical charge. So here if you see the engine, on the engine some beam is mounted which is having a piezoelectric material. So this piezoelectric can convert the engine vibration into the charge, and if it is mounted in the electrical vehicle, it can be reducing the power requirement. It is the micro, at present it is at the microwatt level, but with the development of the technology, it may be changed to the watt level or megawatt, kilowatt level also. So there is one aspect. If you see as we walk, we can generate the energy. So this shoe harvester has been developed, which is mounted inside the shoe sole. And when we walk, this can be generate the power and which can be used to power the maybe Nowadays, we see that when we are going for the morning walk or jogging and other purpose, we have some gadget with us and that uses the power. So that power can be supplied by these type of harvesters. So instead of charging them separately, it can be automatically powered. Some rotary harvesters are also being developed, just like windmill is there. So we can generate the power through the rotations. Another future aspects, interdisciplinary aspects for the mechanical engineering is the biomedical engineering, as I told you. Here is an example where the mandible, jaw basically, our human jaw, it has been modeled, it has been analyzed for the stress, and then the artificial, if something, there is a breakage of the jaw in this, then how the artificial uh, bone or artificial mandible joints, they can be placed without much developing much stress on the other parts of the body. So simulations can be done and all that. So here it has been basically imported from the CT scan data that it has been converted to finite element model, and then with the help of NCs, it has been analyzed for the different large. Right? This is another example where the team at IIIT DM they generated some 3D printing of the biomedical plant from the CT scan data. So CT scan data of this person was done, and then a prototype has been developed, it has been analyzed, and then the doctors perform the surgical operations on the person, and you can see the later on figure. Another aspect is the condition monitoring. I had already told that we can analyze the vibration, we can analyze the sound. Still, the acoustic analysis is still at the developing stage. Human beings, we can analyze that whether the sound is coming from my back or from the front or from side, what is the pitch, who is calling, and all that analysis, right? So the same thing can be used for analyzing the machine performance. If something goes wrong with the machines, can we take a preventive action with the machines? Or how long I can run the machine without damaging the other parts? So all these require the AI and machine learnings also, because the data generated from the vibration or acoustic signals, they need to be analyzed using the tools. And there is a lot of research going in this field. Lot new algorithms have been developed, machine learning algorithms, AI-based support vector machines, and other things have been developed basically. Okay. So these are the technologies we see now. If we see the key skills required for the future mechanical engineering career, I had taken it from the 2019 conference where a critical look at the mechanical engineering curriculum, assessing the need, was presented. And you can see the coding. So being a mechanical engineer, you cannot say that the coding is a job for the computer science engineer. It is the coding is required. You have the R programming, you can get the skill for the Java programming, Python programming, programming for the MATLAB, because MATLAB is being used for the various simulations. So these coding technologies will enhance the mechanical engineering career. CAD requirement, SolidWorks, AutoCAD, ANSYS, Abacus, these technology, and then it's how to convert the CT scan data to these. So all that require the CAD knowledge. So CAD is another requirement for the future mechanical engineering. Knowledge of the microcontrollers, because everything with Industry 4.0, the electronics is embedded with the mechanical engineering. So we need to learn the Arduino, Raspberry Pi, microcontroller, how to program the microcontroller so that we can control the things. So that technology is required. The knowledge of the electrical motors, sensors, and circuitry. That is also required. What is a DC motor, servo motor, stepper motors? What are the different sensors we can use? How we can manufacture the sensors? All these aspects are. How we can build a small circuits also that can also help the mechanical engineer, because we cannot depend on the electronics engineers wholly. But initial knowledge will always be helpful for a mechanical engineers also. Then manufacturing, both subtractive and additive aspects, learning of the new manufacturing technologies, new developments in the manufacturing like 3D printing. Nowadays 4D printing is also came up. So we have to learn them actually. Quality control, so Six Sigma is there. Then FEMA analysis, DFEMA analysis, they are also requirement for the current and future mechanical engineering. Engineering dynamics, system control, that is always a demand. It was previously also and now it is also. Data analysis, data science also is there, right? So these, if you see, these are aspects which includes all the disciplines. They are not limited to mechanical engineers. They are having all the aspects for the mechanical engineer. And in addition, these aspects, creativity, communication, modeling, etc., teamwork, critical thinking, ethics are also required. Right? If I look for the future, this was, I'm sorry, I did not place the source, but this was the future outlook proposed by one of the energy harvester basically. So if you see this pocket, so the cloth may be having some nanowires, which when we move, the movement of the clothes are captured and that can be converted to charge. So that is what is being shown here. The hearing, so sound waves are coming. So if a person requires a hearing aid, so to power the hearing aid, if the sound from the sound waves which are coming to our ear, if we can extract the power from that, and then it can be used for powering the hearing aid. So the dependence on the external battery can be removed. When we are writing something, so there is a touchpad, because everything is now a computer based. So this is a tablet. And now when I write with the help of this, if there is something inside this which can, by pressure, piezoelectric is for example. So piezoelectric, when we place, the charge is generated. So when we are writing, as we are moving, the charge can be generated and it can be used to power the this monitor, or it can be some devices, right? As we move in knee, actually some knee devices are required. So we can have some devices which can monitor the condition of the knee, because one of the major problem nowadays is the knee, degradation of the knee. So we can mount some device which can be self-powered and that can monitor the condition of the knee, degradation of the knee, and then it can be self-powered, right? So this was the technological survey by the basically the future of job survey by the World Economic Job, and you see the technologies. There is an increasing demand of these in order of priority: data analytics and scientists, AI and machine learning specialists. These are big data specialists. So that was the top 20 job roles basically demand in the industries, and based on that, the today's requirement, or you see that IITs and other institutes, they are opening the streams like AI and machine learning streams, data analytics area. They are opening their programs based on that. But here also the mechanical engineers can also play an important role. Data analytics, particularly AI and machine learning specialists, we have the opportunities and we can flow. Process automation is another direction you can see. Software and application development, Internet of Things development, project managers, business service and administration team managers. So industrial engineering people can play an important role there, right? So likewise, we have a lot of demand for this. So towards the end, I go for from the same report, there was the technological adoption in India. So cloud computing is now being 98% of the adoption is already being done. Encryption and cybersecurity, 95% is done. In IoT and connected device, 90% means there is a gap of 10% adoption in the India. And this gap can be filled up by us. AI and machine learning, 19% gap is still there. Robots, you can see 23% gap. This 23% is very large gap basically, right? And I'd already discussed these skills. So the same skills are applicable for the in India also. And with the government schemes which are having focus towards the Make in India and Digital India, Atmanirbhar Bharat, the manufacturing or mechanical engineers are having lot of role to play and with in multidisciplinary aspects. So in the end, I can say that future is bright, but if we adopt to the technological changes and focus on the interdisciplinary aspects, we have to focus towards the more hands-on learning. And in this case, the internship and projects can help a lot. Thanks for the patient listening. Thank you very much. I think I've taken more than the time which was allotted. Sorry for the
No, sir, it's perfect.
yeah. So
Thank you so much, sir. Now I would like to ask the participant if you have any query, you may please raise your hand by using that particular icon. Sir, okay. Hello.
yeah.
Yes, please ask your doubt. Hello, I have unmuted you.
Yeah, good afternoon. I am audible.
Yes, you are audible.
Yeah. So my question is that now people have started talking about digital twins. So can you please throw a light on that? So how it's going to, the
Okay.
future and influence of this digital twins?
Digital twin is basically what we are doing is we are converting. Suppose you have a machine, for example, CNC machine, right? So CNC machine, I can just replicate it on my computer. So machine is there. The machine is having different sensors which are monitoring the conditions of the different, maybe what is the, being a mechanical engineer, I always take the example of the lathe machine basically. So if I have the lathe machine, so we have the simple turning job. When we want to do the simple turning job, what we require is a correct feed, depth of cut, correct speed, digital. Now what we can do is we can mount the sensors which can basically, these sensors can record or they can transfer the what is the current feed being given by the feeder. Basically, the you have the carriage and this. So what is the RPM of the spindle? You can have, and then it will be shown on your digital computer. So you have a replica of that, and you can analyze whether the conditions which are given feed, whatever is the feed required, whatever is the depth of cut, whatever is the speed, whether we are getting it correctly. And then in addition, we can, if we mount the sensor, which can, a image processing type of sensor can be mounted, which can record basically that what is the condition of the job piece. We can have a temperature sensors mounted along with that also. So if the heating is increasing, we can increase the flow of the coolant also. So these all aspects from a remote place also we can control it, the whole machine systems. That is the aspects basically digital twin means. Is it clear?
Sir, Mallika Arjuna, I have unmuted you. Please ask your query.
Yes, sir. Yes, sir. Thank you.
Oh.
To extend that questions, what would the future of digital twins? In the extended question, what future of this digital?
Your sound
Can I
is
repeat, sir?
breaking actually. Can you repeat that?
Will you please repeat your query?
Sure,
Actually,
sir,
your
sure.
voice is not clear.
Yeah. I'm repeating that question. Yeah, I understood what is the digital twins. To extend that question, so what would be the future of this digital twins?
Obviously, nowadays everything is controlled by the with the increase of the cloud computing, cloud-based system in Industry 4.0. If we see, digital twin plays an important role. I give an example basically that previously at our place we were having some machines. So these machines were having some problems. So we have to call the engineers. Maybe some machines are imported, so the engineer has to come from the outside the India also, or right. So that requires some downtime basically. Till the engineer come, we cannot analyze what is the condition of this machine. But nowadays, what is happening is that these machines, they are recording their data. Just like our flight, you might have read about the black box in the flight. So they record every data, what is happening during the flight. So similarly, we can have here also, in industries also, these machines, they are having some type of black box, which is recording the data related to machine working. And now the engineer, basically what it is doing, this data is sent to the remote place, whether the engineer it is at the USA or it is Germany, he can assess that data, he can analyze what is the problem with this, and then if small action is required, it can be instructed to the uh, engineer or worker working there. So it can be correlated basically. So here also the digital twin is required basically. All the machine and its replica is required basically. And right?
Thank you, sir. One more query from Shashi Kumar Jain, sir.
Yeah.
Shashi Kumar Jain, sir.
Yes, madam.
Sir, please ask.
Yes, madam. Thanks a lot. Firstly, thanks a lot, Gupta sir, for your kind presence in this session, for a wonderful talk. And thanks a lot, Dr. Amit Datta sir also, and Sanju Chaudhary madam also. Sir, my question in this session is, for a wonderful presentation session on project, it was really nice listening to all the talk. Being head of the institution at Technocrats Institute of Technology and Science, Bhopal, sir, my concern is, like as you told about energy harvesting, the concern is none of the state government or nodal agencies, they are really interested in listening to the words of engineering institutions. Like in a disintegrated manner, we are working. I plan to say the otherwise, whether it is smart city development or anything related to the overall development of the nation, such kind of seminars and presentations must be organized on a regular scale, so that in a city like Bhopal, where more than 100 engineering colleges are there, a student can come up and listen to such things and they can be a party to the overall development of the nation, sir. Matlab, like, why can't we work on a model like this? Since I got the mail from AICT and got to know that you are going to address the session, I attended the session along with my faculties and the students. But it is once in a while kind scenario. My request is to Gupta sir also, to Amit Datta sir also, Sanju madam also, we must emphasize, organizing these kind of seminars so that student can work in a holistic manner. That too, since last 2 years, like due to Corona pandemic, due to online learning mode, overall learning has been hampered to a greater extent in this particular field, like mechanical, electrical. So I feel that this becomes a collective responsibility to a learned professional like Gupta sir also, and Amit Datta sir, like you are with the AICT, Sanju madam, you are with the AICT. We need to organize such seminars on a larger scale for the overall development of our students. This is my request.
Thank you, sir. Sir, I would like to inform you that this is for your information. We have already organized 10 plus such project guidance webinar. We are working on it, sir.
Yeah, madam, already I am asking my students and faculties to attend all these seminars. But
Okay.
madam, the concern is, madam, like being at Bhopal, Smart City Development Corporation is working over here.
Yes, sir.
But we never hear anything from there that what kind of project they are executing, what are the policy guidelines of the MP government, what are the policy guidelines of technical university. There should be a coherence between different bodies.
Yes, sir.
Then only there will be a real-time learning for the students. We can depute our students to different places located in and around Bhopal. They can have a real-time experience.
Yes, sir.
Then it can be possible, madam.
Yes, sir. So this is the
Yeah.
motive of AICT that all students from all over the country should learn how to other people working on the different projects.
Yeah.
Yeah,
So
Dr.
that's the
Thank you.
principle. To have an
Yes, sir.
integration.
One thing I
That's
wanted
the
to add to here actually that if you see last 2 years, AICT is also working for this. They have the ATAL programs basically for it. Mostly they are the FDP, but I request AICT also to look from the students' point of view.
Yeah.
FDP, we register the students also, mostly the PG students, but UG students can also be registered. And if we focus on the UG students, they have lot of enthusiasm and they require such type of seminars to be open to them. I observed this when I was part of some of the FDP. I delivered the lectures there, and similarly the MIT Ministry of Electronics, they had also a scheme of electronics and ICT academies. They are also running number of such programs. But the major challenge is that the hands-on training, basically.
Yeah.
We can
That's the point of concern
theoretically
for
we
all
can
of us, sir,
discuss,
basically.
but practical knowledge will be only when we are at the real side, and then large number cannot be benefited. Only we can accommodate in a small number, maybe a base size of 50 or like that only. So that is there, and I think government is working towards that. As I know.
And sir, I would like to add one more thing that all the project guidance webinar that have been conducted so far is available at public domain on YouTube channel of AICT,
Right.
Media AICT.
Right, ma'am. Thanks a lot, madam. I'll share it with the students also.
Okay, thank you so much, sir.
Thank
Sir, Mani Makela, sir, if you have any query, please ask your query here, sir. I have unmuted you, sir.
Yes, madam. See, my
Mani, sir? Yes.
technical question. What kind of manufacturing methods are used
Yes.
to make, train axles, whether forging or turning in the lathe roll? I don't know. I want to know that, the bigger scale,
Sir, can you be slightly loud? Actually, I could not hear you properly.
Train axles, this train axles, sir. What kind of manufacturing methods are used to make that?
What type of manufacturing?
Methods to make, to larger
Methods.
scale. Train axles, bigger way. All size train axles are there, right?
Actually, your voice is not coming clear. Can you type on the chat box?
Yes, Mani, sir, you are requested to please type in the chat box. I will read it.
Sorry, okay. See,
Okay.
okay, leave madam. That's fine. Already typed,
Okay,
If
sir.
you had already typed in the chat box, just I will see today.
Any other who want to ask
In
any
between, we
query?
can take another. I will ask, just see if I can get the question in the chat box. In between, you can ask another question and I will.
Please raise your hand if you want to ask any
There
query,
were
if
some
you have any
questions.
doubt related to it. Please raise your hand if any doubt. Sir, we received one query from Hari Prashant V. Sir. What is
Yeah.
Industry 5.0?
Okay. Actually, at present, I'm also not having much knowledge about that, but I'd heard this term that Industry 5.0 is coming. But I'm sorry, at present I can't give you because I don't have any knowledge on this aspect. So
Okay,
I
sir.
have
Sir,
to
he
go
is
through
asking
that.
one more query. In
Yeah.
future, 3D and 4D printing will replace the existing conventional machines or not?
No, we can't replace the conventional machining, all the conventional machinings, right? So the role of the conventional machines will still be there, but 3D and 4D printing is taking over of some of the jobs, basically. You can say that.
Thank you, sir. Sir, Manikal sir wrote in the chat box that which manufacturing methods used to make train shafts, axles?
Crankshaft,
Yes, sir.
that's it. So crankshaft and axle, actually, I am not an expert from the manufacturing point of view, but as I remember, basically, uh, casting is done, and then they are basically casting is being done for that, as I remember. But I am not an expert, so it is better I should not answer that actually.
Okay, sir. And sir, one more query from Brijraj Singh. Which type of industry should we focus on, or we should keep our target to join?
Future is basically the manufacturing industries are always automotive and manufacturing industries. They are from the beginning and they will remain forever. Only thing is that we have to train ourselves so that whatever changes in the industries are coming, we have to make ourselves ready for that. And that is what was my today's theme basically, that what are the changes are coming in the industries and how, what technologies we can adopt, what learning skills we can adopt. So particularly the programming is one aspect, and then mechatronics aspects are required.
Thank you, sir. Sir, one query we received on our YouTube channel chat box from Sanjita Namata. What are the research aspects of mechanical engineering in universities?
I'd already covered the aspects which are from the interdisciplinary aspects. There are lot many aspects regarding the mechanical. For example, I take the example for myself, the students under me, they are working on the condition monitoring. So the development of the tools means measurement of the signals, then their analysis, and then data analytics is there, and then developing the algorithm so that we can detect the fault of the machines. In addition, we can make some predictive, uh, basically the predictive forecasting methods, or we can forecast the what will be the remaining life and other things. That also, so predictive analysis is also being done. That is one aspect in which the students work. Another aspect is the energy harvesting. Energy harvesting means that from whatever vibration or the waste energy is there, how we can convert them to the useful energy. So I've taken some examples like engine energy harvester or the shoe walking harvester and other harvesters. So the basic purpose of energy harvester is that we cannot generate the macro level energy, but we can generate the micro level energy, and particularly with the development of the IoT based systems, where the remote places also the things will be there and the power shortage is there. So these energy harvesting devices, they can power the system at the remote places, and then they can be used for different. So energy harvesting is another direction. Finite element analysis, biomedical direction, I had already given TMJ, the bone analysis, fracture analysis. Is robotics is another direction, particularly nowadays the focus is towards the human-centric robots. So these are the few from design and mechatronics point of view, because I had not worked towards the manufacturing actually. I am working in this direction mostly. So that aspects I cannot cover, but to give you some basically the incremental sheet forming, industry 4.0 related aspects, you can work on that. Right?
Sir, one query from Virendra sir. There are many students having good mind and gets a new ideas to work on. But many students are there who have skills to do something research, but they don't have ideas. So can we get a correct domain and the projects on which we can work?
Yeah, there are aspects, basically, there are aspects. For example, if I take the condition monitoring itself, you can perform the experiments, you can collect the data, and then data analytics can be done. So that is from the second point of view. And first point of view, the student having idea, they can generate the algorithms for enhancing the data analytics and other purpose, or predicting the life and other aspects. So like that, it can be done. But I don't think that every human mind, they are having some creativity in their mind. So it can be, if it is properly channelized, it will be always useful. So you cannot say that I don't have any thinking process or I don't have any such thing. You are having, but only thing is you have to identify that what skill I am having and I can work in that direction. Right? There was a
Yes.
question in the chat box, actually I was posting. Yes, Solanki has asked, is there any further branches which are connected or compounding with mechanical field? So I had already given that aspects basically. All the aspects, make electronics, computers, they are now interconnected. So we are going towards a multidisciplinary actually. Yeah,
Yes.
you have
Sir, another query from KC Rath sir. What are the required skills in technology that mechanical engineering students have to upgrade now based on industrial requirements?
So I think I had already answered that in my talk also, that the aspects related to other domains. Computing is one my major thing which is required nowadays. In addition, the knowledge of the electronics and particularly the microcontroller aspects basically. So that is, and third aspect is the data analytics.
Sir, another query from Lalita ma'am. Will you please tell us advantage of rapid prototyping over 3D printing?
Rapid prototyping is basically 3D printing has started from the rapid prototyping aspects from because I am not a domain expert from that aspect, but as I understand this, initially this 3D printing was given, the rapid prototyping was there, and the aspect of the rapid prototyping was that how we can build the prototype of the actual component, and then we can do the experiments in other. And nowadays 3D printing has taken, so instead of prototyping, we can use it for the actual printing also. As I remember, but I am not an expert, so this cannot be taken as the words basically that.
Yes. Sir, one query received on YouTube chat box. How artificial neural network is helpful in mechanical engineering?
Okay, so I had already told that the AI techniques are being used for various analysis purpose, and ANN is one of them basically. So I give an example. For example, if I am developing a robot, because I discussed that in social robotics. In social robotics, the robotic arm, if I am making a robotic arm for a handicapped person, and I want that he should be working uh, by his own, basically, without the help of, he does not want help of the others, he wants to work. So basically what we need to do is we have to analyze first how our human mind is working. So we take the EEG based signals. These signals need to be classified based on the activities of the mind. There are channels in our mind, and these signals which are generated, they need to be analyzed, they need to be classified, and based on that we can take the action. So ANN can be one of the tools which can be used for this purpose, that if we are getting such type of signals, what should be our action, and accordingly we can give the action to the R which can perform the required task.
Sir, last query. Nowadays, the mechanical engineering students, what kind of software tools are required to upgrade their knowledge? From Kathiravan, sir.
What type of? Just repeat it.
Sir, what kinds of software tools required to upgrade their knowledge?
So the software tools, obviously you have to learn some language. I had already shown in my last, but one slide actually. Python programming is nowadays popular. MATLAB, not MATLAB, basically programming in the MATLAB is also one of the major requirements. And then when we are using these CAD softwares, we have to convert our files from some CT scan data to STL and other things. So we have to program it, all these aspects. So these CAD softwares, they have their own requirements, which can be connected with the either C language or Python or their own. For example, in this NC software we use, there is already a script which we can use. So we can learn them and that will be helpful.
Yes. Yes, sir. Sir, should we take, sir, last query from Sanjay, sir. Is there any scope of refrigeration related projects in mechanical engineering?
Refrigeration is always a part of mechanical engineering, right? So
Yes.
there are the requirement that we should replace this refrigerant, means how we can make them low powered, or whether we can use some conventional way of refrigeration which does reduce the requirement for the energy basically. Because these ACs, particularly air conditioners, they consume lot of power. So how we can, and then they generate lot of heat outside. So how we can balance the environment with this, that is there, right? Okay.
Yes. Okay, thank
One
you.
more thing, actually, Professor Mani Mekala, I think he has asked about the manufacturing methods used to make train shafts, axles, right? Okay.
Yes.
So for axle, actually, because I had worked in the NBC, so they were manufacturing it by the turning machines, basically. They were generating it with the turning operations. So they use the CNC or AC based machines for this purpose.
Okay, thank you so much, sir, for such a useful information, which will definitely help those students who really want to do projects in this area. On behalf of AICTE, I feel immense pleasure to propose vote of thanks on this event. I want to express my sincere gratitude to Professor Vijay Kumar Gupta, sir, for enlightening us with their knowledge. So today's webinar was full of knowledge. Thank you, sir, for such a wonderful information. I'm pretty sure that the precious knowledge that you have shared with the attendees will definitely help them in their projects. Thank you so much, sir. I thank Dr. Amit Datta sir for organizing such type of project guidance webinar. I would also like to thank all the participants present here for paying attention and learning. And I also want to thank Mr. Brij Mohan, our IT consultant who really worked hard to make this event successful. In the end, thank you all for being with us from starting to end. Have a wonderful day ahead. Thank you so much, Gupta sir.
Thank you, madam. Thank you, Datta sir, for giving me this opportunity. And if anyone has any questions, they can ask me. I'm sharing my email ID in the chat box. You can mail me and you can ask the questions. Whatever little knowledge I have, I can try to answer you. Thank you. Thank you very much.
Okay, thank you, sir.
Okay. So I'm leaving now. Okay.
Okay.